an exponential equation, the first thing to notice is that the variable is in the exponent. So we have to do everything in our power to get the base and the exponent isolated. Once that happens, then we can either get a common base or we can take the natural log. So I want to just go over this question number 46 where we look at it and we say, okay, my little variable is in the exponent here, variable is in the exponent, so we have an exponential equation. We then want to isolate the base plus the exponent. So here my base is 9 and my exponent is the x plus 6. So that is an isolated base plus exponent. Same thing goes on the other side. We have an isolated base plus exponent. So to focus on the particular method of getting a common base. A common base means that you have only one number repeated in the factor tree. So when you think about 9, your common base cannot be 9 here because when you draw 27's factor tree, you have 9 and 3. So because of that presence of 3, 9 cannot work as a common base. So in this case, 3 is going to be our common base. So our 9 is going to be replaced with 3 squared. So when we make that replacement, it is not just the x that is going to get the 2, but also the plus 6. So all of this 3 squared is then going to have an exponent of x plus 6. Now, the 27 is equal to 3 to the third power. So we are going to replace 27 with 3 to the third, and then it's raised to the x minus 5. Now, be super careful here. It's not just 2x plus 6, because when we have an exponent to an exponent, we need to multiply those exponents together. But because there are 2 terms in the second exponent, this 2 is going to get multiplied with the x, but also with the 6. And the same thing goes, this 3 is going to get multiplied by both. So this will become 3 to the 2x plus 12 equals 3 to the 3x minus 15. Now, once we have our common base, we can say that those guys are going to cancel. One-to-one property says that it's just going to be the exponents that we can set equal. Okay? And then we look at the equation that we're left solving is now a linear equation, x to the first. So we just move the x's to one side. In this case, I might decide to subtract 2x from both sides. And I would get 12 equals x minus 15. Add 15, add 15. We get 27 is equal to x. And that is our answer. So again, getting a common base, it has to be one number that's repeated. That one number that was repeated in all the factor trees here was 3. But the key step is that we have to distribute this 2 to the x and to the 6, this 3 to the x and to the minus 5. And once we do that, we set them equal and then solve the resulting equation.